If you've ever wondered where Transformers really began, this is it. Back in 2014, Seek-to-Seek translation had a stubborn problem. It crushed the entire input sentence into a single fixed vector, and on long sentences that summary just fell apart. Then a paper from Bahdanau, Cho, and Bengio proposed a fix that looks almost obvious in hindsight. Let the model look back at the whole input and pay attention to the parts that matter. That single idea became the seed of modern AI. Let's see how it works. The mechanism is easier to grasp if we watch the decoder produce a single word. Here's what happens at each step. Picture the decoder about to emit the next word of the translation. In plain Seek-to-Seek, it would only have that one fixed context vector to lean on. Bahdanau's version gives it something far richer, direct access to every hidden state the encoder produced while reading the input. So before committing to a word, the decoder scores its current state against each of those encoder states. A small learned network, the alignment model, asks a simple question for every input word. How relevant are you to what I'm about to say right now? Those raw scores then pass through a softmax, which squashes them into weights that add up to 1. High weight means that source word matters a lot for this step. Low weight means ignore it. In effect, the model spreads its attention across the input like a spotlight. Finally, it blends the encoder states together using those weights, producing a fresh context vector tailored to this exact moment. The decoder generates its word from that, then repeats the whole dance for the next word, with a brand new focus each time. Now, contrast that with what Seek-to-Seek was doing, and the leap becomes clear. Plain Seek-to-Seek gave the decoder exactly one context vector for the entire input, computed once and reused for every output word. On a short phrase, that's fine. But on a long sentence, it's like trying to translate a paragraph from a single blurry snapshot. Detail near the start gets forgotten by the time you reach the end. Bahdanau attention replaces that with a fresh, weighted context at every single output step. Generating the verb, the model can lean on the source verb. Generating a name, it leans on that name. Nothing gets crushed into one summary anymore, and long sentences suddenly translate cleanly. Let's distill the 3 ideas that make this mechanism matter. Rather than relying on one summary, the decoder attends over all of the encoder states. It keeps the full input available and reaches back into it at every step, so no information is ever forced through a single narrow vector. The focus itself is learned. A small alignment network scores how well the decoder state matches each encoder state, and a softmax turns those scores into weights that sum to 1. Nobody hand-codes what to look at. The model figures out the alignment on its own, and the payoff was huge. Translation of long sentences improved dramatically, and you could even read out which source words mapped to which output words. That query the whole input idea is exactly what self-attention and transformers went on to generalize. All right, 4 things to take away from this one. Bahdanau attention from Bahdanau, Cho, and Bengio in 2014 was the original attention mechanism built to fix Seek-to-Seek's fixed vector bottleneck. Instead of one context vector, the decoder looks back at every encoder state and, at each output step, blends them into a fresh, weighted context. Those weights come from a small learned alignment network passed through a softmax, so the model learns where to focus and even produces readable alignments. It dramatically improved long sentence translation and introduced the query the whole input idea that self-attention and transformers later generalized. If tracing the roots of today's models is your thing, you'll find plenty more of it over at standardy.com. Catch you in the next one.